Good morning, class. We are looking at exam 3 review covering section 3.5, the chain rule, implicit differentiation, related rates, 3.7, derivatives of the log functions, 3.8, differentials, 4.1, maximum and minimum values, and 4.2, how derivatives affect the shape of a graph. First, we have a lot of differentiation formulas we should be very comfortable with. Then we are looking at the differentials. F of x plus delta x is f of x plus delta y precisely, and delta y can be approximated by dy. A pair a comma f of a is used, giving rise to the tangent line known as linearization, and you can use the point slope. That's good enough. You don't have to memorize this formula. Logarithmic properties, if we look at this box and then this arrow, which means b to the power of y equals x, so the base is the same for both of them. The exponent is y here, the same as here. The argument becomes x. Then we can follow these properties by understanding the concept of this arrow. For example, b to the power of 0 is 1, b to the power of 1 is b to the power of x is b to the power of x, and the rest of them we've looked at the proof in algebra. For common log, log base 10, we don't write the base. Log x means the base is 10, and we can write the properties and formulas for common log. If the base is e, we call it ln x, and again we can write the properties for natural log. And exponential functions and logarithmic functions are inverse functions. Therefore, if you graph them in the same set of axes, they are symmetric with respect to the line y equals x. And here's a change of base formula. If you want to evaluate the log with different bases, you can use the common log or the natural log. As far as their derivative is concerned, ln x, you just flip it over. G of x, you flip it over, you multiply by g prime using the chain rule. And if the base is not e, you also tag along 1 over ln b. So let's use implicit differentiation to find dy dx or y prime for 2x plus y to the power of 4 equals x minus 2y. We are going to use the extended power rule. 4 sits in front, 2x plus y cubed. Then we need the derivative of the parentheses, which is 2 plus the derivative of y. You can write dy dx of y prime. On the right side, x gives us 1, minus 2y gives us minus 2y prime. We are done with calculus. We are going to solve for y prime. To do that, we are going to distribute here. So when we multiply the blue part by 2, we get 8 times this. And then if we multiply it by y prime, we just write it as a 4 times 2x plus y cubed times y prime. Now again, bear in mind, this is the only calculus step, everybody. And now everything is algebra. To solve for y prime, we bring everything involving y prime to the same side, meaning we are going to move this to the left and make it positive, move this to the right and make it negative. And on the left side, we factor the y prime out. So the left side becomes y prime times 4 times the product of 2x plus y quantity cube plus 2. And if you divide both sides by these brackets, what's inside the brackets, you're done. Needless to say, you can factor the common factor of 2 from the denominator. It doesn't change anything. In other words, you always have to look at the result and see if you can simplify it further. This cannot be simplified further. Example 2, use implicit differentiation to find dy dx when sine y plus 2x cubed y squared equals 6. So to differentiate this, first we notice this uses the product rule, so we're going to throw in a raised dot to make sure everybody understands what's going on. Sine gives you cosine, so the answer is cosine y dy dx. Now 2x cubed times y squared, I'm going to write f times g, and I'm going to use the product rule on that. 2x cubed gives me 6x squared times g y squared plus g prime f. Now y squared, the extended power rule, the derivative of g of x to the power of n is n g of x to the power of n minus 1 g prime of x, or y to the power of n is n y to the power of n minus 1 y prime or dy dx. So in this case will be 2 y prime. Because we use dy dx here, we're going to use dy dx. And by the product rule times f, 2x cubed, any number results in 0. Again, done with calculus. This is the only calculus step. Because we are solving for dy dx, we are going to move this to the right, and we're going to rewrite this as a 4x cubed y dy dx. So we move 6x squared y squared to the right becomes negative. And on the left side, we are going to factor out the dy dx from the first and the third term. So this gives us cosine y, this gives us 4x cubed y, and this moves to the right becomes negative. All you have to do, divide both sides by the parentheses, and that gives us dy dx. Find an equation of a tangent to x squared plus 2xy minus y squared plus x equals 2 at the point 1, comma 2. Remember, in order to find the line, you need a pair, x comma y is given, and you need the slope. To find the slope, you have to differentiate. So we are going to differentiate this implicitly, and what we have here, x squared, the answer is 2x, then plus 2xy we use the product rule on that, f prime g plus g prime f. So this is 2 times y, and this is y prime or dy dx times 2x. So this is f prime g plus g prime f minus y squared minus 2y y prime. X gives us 1. Any number such as 2 ends up being 0 when you differentiate. Now, we are going to keep anything involving y prime and move everything else to the right, 2x, 2y, and 1, and all of them take a negative sign. On the left side, we are going to factor the y prime, although we can factor out 2y prime is y prime. Divide the right side by the parentheses, and that's y prime. By the way, class, we could have, after we found this, we could have plug in x equals 1, y equals 2, and will give us y prime, which becomes this rule. But I wanted to go through the process of finding y prime. Again, you don't have to. If you plug in 1 and 2, you get 7/2. So let me quickly show you. Negative 2 times x, which is 1. Negative 2 times y, which is 2, minus 1, over 2 times 1 minus 2 times 2, which results in negative 7 over negative 2, which is positive 7/2. Now, using the point slope, y minus y1, meaning y minus 2, equals m 7/2 times x minus x of 1, meaning x minus 1. So the right side is 7/2 x minus 7/2 negative 2 moves, becomes positive 2 or 4/2. Y becomes 7/2 x minus 3/2. Example 4, find dy dt for the equation x e to the power of y plus 4x equals y cubed, where dx dt is 2, x is negative 1, y equals 0. The moment you see dt, you recognize t is the independent variable, which means the derivative of y is dy dt, the derivative of x is no longer 1, it's dx dt. So we are going to differentiate this implicitly with respect to t, and I'm going to put a raised dot here. And use the product. So x gives you dx dt times e to the power of y, this is f prime g, plus g prime f. E to the power of y, remember exponential is always itself, it's e to the power of y, times the derivative of y, which is dy dt, times f, which is x. In other words, right here, we have f prime g plus g prime f. Now, 4x gives us 4 dx dt, y cubed, 3y squared. Instead of dy dx, we're going to say dy dt, because t is the independent variable. And basically, you can solve for dy dt or just plug in because they have given us a bunch of values. It's faster if we plug in, meaning replace the dx dt with 2, e to the power of y, replace it with 0, y, replace it with 0, dy dt is missing, x, replace it with negative 1, dx dt is 2, the right side, 3 times y is 0 squared times dy dt. So e to the power of 0 is 1. So that's 2. And then this is 1. That makes it minus dy dt. 4 and 2 result in 8. The right side is 0. Now 2 and 8, they add up to 10. And this moves dy dt is positive 10. Differentiate f of x equals 2x times ln of 3x squared. Although ln of 3x squared can be decomposed into ln 3 plus 2 ln x, it's easier actually to keep it this way for this case. So we are going to throw in a raised dot between 2x and ln of 3x squared. So therefore, we are using the product rule where this is f, this is g. We are using the product rule on that. So f prime is 2 times ln of 3x squared plus now the second piece, ln of 3x squared, flip it over, 1 over 3x squared, flip over the argument of natural log, so 1 over 3x squared. By the chain rule, I need the derivative of that, so we are here in essence, right? So 6x. And going back to the product rule, g prime f, now I need f, which is 2x. And this is the end of the calculus. Now, this is, of course, 2 ln 3x squared. This one is 12x squared divided by 3x squared, which is 4. So pretty straightforward, everybody. All right, we want to differentiate this. And if you want to differentiate the way it is, you have to flip this over. That means write the reciprocal. And then differentiate this using the quotient rule. You don't want to do that. That's a long way to do so. So an easy way is to decompose this. Can anybody tell me how we decompose this? We can decompose this using the quotient rule first. The derivative of the top ln of 5x minus the derivative of the bottom ln of x squared plus 5. And furthermore, ln 5x, we can use the product rule on that and write it as ln 5 plus ln x. Even if you work on it, it's decent enough, you can handle it. But this is the fastest way of doing that because ln 5 is a number, everybody. The derivative of any number is 0. So this gives us 0. This gives us 1 over x. Ln of x squared plus 5, we are here. We are going to flip this over. 1 minus 1 over x squared plus 5, and then times by the chain rule times the derivative of the inside, which is 2x. And again, I'll recommend you always write the formulas that you want to use and then follow that. It goes a lot faster if you do so. All right, so now how do we finish that? We take a common denominator of x times x squared plus 5. And to take a common denominator, this is 1 times x squared plus 5. And this is minus 2x times x. So the numerator is x squared plus 5 minus 2x squared. And we can combine these two into minus x squared, and we are done. So the final answer is minus x squared plus 5 divided by x times x squared plus 5. Decomposing the log makes it easier and faster to differentiate. G of x is log of 9 minus x cubed to the power of 4. We want to differentiate that. And we're going to decompose the log by using the power rule and putting number 4 in front first. Now differentiation is easy. 4 doesn't change. It's a coefficient. It remains. Flip this over. 1 over 9 minus x cubed. By the chain rule, I need the derivative of that, g prime of x. So if you call this g of x, so 9 minus x cubed, the derivative is negative 3x squared. And finally, I look at the base. The base is e, no. So 1 over ln of the base is 10, 1 over ln 10. So what is in the numerator? 4, 1, negative 3x squared, and 1. Their product is negative 12x squared. And the denominator is 9 minus x cubed times ln 10. Example 8, y is f of x equals x squared over x minus 8. We want to find dy. Remember, f prime is dy dx, and dy is f prime of x dx. The moment they ask you for dy, first and foremost, find f prime of x. We are going to use the quotient rule on that. So f prime of x, or dy dx, is the top, which gives you 2x times the bottom x minus 8, minus g prime f minus the bottom, that the derivative is 1, so minus 1 times x squared. And now g squared, the bottom you write it in a parentheses and square. Done with calculus, we are going to simplify the numerator as follows. Two x squared minus 16x minus x squared. We can combine these two into x squared. So it becomes x squared minus 16 x over x minus 8 squared. Although you can factor the x out, x minus 16 is the result, nothing simplifies. So what is dy? Exactly the same thing times dx. Find dy and delta y when x is 4 and dx or delta x is 0.2. So let's plug in into this. Let's start with this one. Goes x equals 4 and dx or delta x equals 0.2. So we want to evaluate this at these given values. So this is simple. This is 16 minus 64, and this is 4 minus 8, negative 4 squared, which is 16. So 16 minus 64 is negative 48. Divided by 16, you get negative 3 times 0.2 is negative 0.6, and we are done. For delta y, which is f of x plus delta x, it's f of 4.2 minus f of 4. This is basic math, elementary algebra. Go to the original function, replace the x with 4.2, you get 4.2 squared over 4.2 minus 8. minus, replace the x with 4, 4 squared over 4 minus 8. Now either do it by hand or use a calculator. You get 17.64 over negative 3.8 minus 16 over negative 4, which is negative 0.6421. Two things. Number one, these two values are close, pretty close. Number two, this seems to be easier to evaluate than this one. Number three, the closer the delta x to the value of, the smaller the delta x to the value in a matter of comparison to x, the better the approximation. In other words, if you make this 0.1, they get even closer. If you make it 0.01, they get even closer. So the smaller the value of delta x in matter of comparison to the value of x, the approximation, the better the approximation. Three point eight differentials. Example 9. Use differentials to approximate cube root of 63.5. And we want to go with the differentials. Meaning f of x plus delta x, precisely f of x plus delta y, will be approximated by f of x plus delta x equals f of x plus dy. That's the meaning of differentials. So first and foremost, you need a function that represents this action, this operation. What function do you think we should use? All you have to do, read this, cube root of 63.5. So f of x is cube root of x. Whatever the action operation does, you do that. The next thing is choose an x to be a number close to 63.5 for which the cube root is easy to compute. Any number comes to mind? The easiest number is 64 because we should know cube root of 64 is 4. So we have the function, we have the x, and from the function on x, we want to go to 63.5. So this becomes the original. This is the new one, 63.5 minus 64 results in delta x or dx being negative 0.5. Meaning, we know square root of 64 is 4. We may not know what is the square root of 63.5, but it has to be less than 4 because this is negative. And to understand this, again, I want to make sure we understand if, for the sake of argument, if we were interested in finding cube root of 65, the x would have been positive 1 because 65 minus 64 is positive 1, meaning I don't know what is the cube root of 65, but it's larger than cube root of 64, which is 4. That's the meaning of it. All right, so let's find the answer. The process is f of x plus delta x equals f of x plus dy. That's an approximation. So we do have f of x. We do not have dy. To find dy, first we need to find f prime of x. To find f prime of x, we're going to change this to x to the power of 1/3. And now differentiation becomes easy because we can use the power rule. F prime of x becomes 1/3 x to the power of 1/3 minus 1 or negative 2/3. This exponent is negative. You can take it down, make it x to the power of positive 2/3 and rewrite it as 1 over 3 cube root of x quantity squared. This is f prime of x. What is dy? The same thing. Times dx. Multiply this expression by dx. So in essence, 1 times dx becomes dx. Now we are in business. We have f of x, we have dy. So f of x from here, dy from here. We are almost done. We are interested in finding the cube root of 63.5, which means we want f of 63.5, which is f of x equals 64 plus delta x is negative 0.5. Into this, replace the x with 64, x with 64, and dx with negative 0.5. So cube root of x becomes cube root of 64. Dx becomes minus 0.5. 3 cube root of x becomes cube root of 64. Quantity squared. So this one is 4. So is this one. 4 squared, 16 times 3 is 48. I want to change the numerator, negative 0.5, into a fractional format, 1/2. So plus and negative becomes negative. The reason I put this as 1/2, the bottom is 48, because 1 over 2 times 48, that means 4 minus 1 over 96. 2 times 48, this is a complex fraction. It makes it easy to see. And if you subtract 1, you get 3 and 95 over 96 precisely. And if you use a calculator, this is the approximation. Calculator. By calculator, I mean using calculator on this part, okay? However, if you put 63.5 into a calculator, this is what you get. Within the first 4 decimals, they are identical. If you want to do the rounding here, this changes to 6 because this is 5, and this changes to 6 because this is 8. So they are pretty close. Why are they that close? Because dx or delta x is extremely small compared to 64. We are done with this. However, I want to remind you of linearization, which refers to the tangent line. So we want to find the tangent line. And we want to find the tangent line at what point? What is the function? The function is cube root of x. At x equals 64. So if I plug in 64, it gives me 64, comma 4. That's my point. What is the slope? We found f prime. So if we plug in x equals 64, becomes the slope. And of course, if you recall, this was 48, right? This denominator, or this is 4 squared, 16 times 3 is 48. So 1 over 40. Now we want to find the tangent line. Y minus y1, we're going to use the point slope. Y minus 4 equals m 1 over 48. X minus x of 1, that means x minus 64. If you move things around, and I'm going to leave it for you to do the algebra, you get y or L of x, or the tangent line, equals 1 over 48x plus 8/3. Now, I want to go back to the curve, and I want to show you, when you look at the curve, precisely at this point, the curve and the tangent line, they give you the same y coordinate. But if you're not at the precise point, they are not the same. However, if you're close to this point, when you plug it to the tangent line, the value is close to the value the curve gives you. And that's the idea of linearization. So one more time. At x, f of x, the curve, and L of x are identical. But if you go to the right or left, makes no difference. They are not identical. But if you're close, the value is close, and linearization makes it easier. So if I want to find cube root of 63.5, I got to put it into this function, for example. That's pretty difficult. If I put it into this, that will be close. And that's the concept. If you put it in, I'm going to leave it for you to evaluate it. It becomes precisely this one, everybody. And of course, it's an approximation with this one. So put 63.5 instead of x, and make sure you find this value.